Hello and welcome to the Geodict 2021 Advanced GeoPython workshop. Before we start, please make sure that Geodict is running on your machine. Also note that if at any point you're lagging behind or if you don't want to follow the workshop interactively, you can also find all the results that we're producing, all the macros that we're typing, you can find in the M2M results subfolder inside your workshop material. My name is Rolf Westerteiger and I did my diploma in computer science in 2008, finished my PhD in 2014 together with the German Aerospace Center and the University of Kaiserslautern, and I've been a full-time senior software developer at Math2Market since 2014. After attending this workshop, you will be able to access simulation results programmatically using GeoPython. You will know how to structure your GeoPython code into functions, which is very helpful when doing automation. You will know how to perform simple automatic material optimization loops. And you will know how to create custom PowerPoint reports based on your simulation results. The workshop consists of 3 parts, where each part is roughly half an hour session, followed by a 10-minute break. During the whole workshop, my colleagues will be available in the WebEx chat to answer your questions, and I will also be available in the break time after each block to answer your questions orally. In the first part, we're going to be looking at macro recording and accessing Geodict simulation results. Also, we're going to be restructuring the macro that we have recorded into functions to make it easy to reuse the code. In the second part, we're going to be looking at loops, automatic material optimization, and plot generation. In the third part, I will show you how you can create custom PowerPoint reports from within Geodict directly from your simulation results. One of the most important concepts in Geodict automation is a so-called command. Almost every action in Geodict is a command, for example, loading and saving files, structures or results, starting a simulation, rendering an image or a video file, etc. Each command consists of a name and a set of parameters, for example, the result file name, the boundary conditions when running a solver, the solid volume fraction when generating structures. And almost all actions in the graphical user interface execute a corresponding command in the backend. And if you record a macro, this macro will consist simply of a list of these commands together with their parameters. And when playing back this macro, it will run the same commands with the same parameters again. Also, macros can have variables which can then be defined in the GUI. But please see the beginner's workshop for GeoPython macro variables, because we're not going to be using them here. Now, without further ado, let us start by diving right into Geodict. First, I would like you to change the project folder, namely go to File, choose Project Folder, select Project Folder. Then we go to the Workshop Materials folder that you should have downloaded. Go to the project folder subdirectory, and once you're in there, click Select Folder. Next, I would like you to generate a simple fiber structure. For this purpose, we go to Model, FiberGeo, go to Create down here, then click Edit. And please, for the voxel resolution, specify 100, 100, 100. Then click OK. This is going to make our simulations faster later. Now please click Generate down here. And now we have created a simple fiber structure, which we can look at in 3D if we want by clicking the 3D icon up here. By the way, if this result viewer popped up on your screen, you can just close it at this point. We're going to be looking at it later in context of simulations. Now we have our fiber structure, and now next step we want to do a simple flow simulation. For this we go to Predict, FlowDict, Select Stokes, Brinkmann, Lear, should be the first entry in this box here. And just click Run. And for now, again, we click Close in the result viewer. Now we have recorded two geodict commands, namely the generation of the fiber structure and the flow simulation. And what we want to do now is we want to save these steps as a macro. For this purpose, we go to the macro menu, go to Session Macro, and here we see several other miscellaneous steps which Geodict has executed in the background. For example, opening the result viewer and closing it again when we click the close button. But right now we're not interested in that. We only pick the essential commands, which is the fiber geocreate command here, which created the fiber structure. So just click it. And the other command that we want is the flowdict solve Lear Stokes command down here, which ran the flow solver. So to select the other one, do a control click. So we have these two commands selected. Then we click Add Selected Commands to File, which will move them down into this box. And now once we click the Save button here, it will save these commands, which are in the box down here, to a Python macro. So please click Save. And now it automatically should prompt you to save it in the project folder. So the folder is already correct, and please name the file workshop1. It will automatically get a .py extension, because it's a Python macro. Then click Save. And close the Session Macro dialog again. Now let's have a look at the macro that we just created. For this purpose, go to the Macro menu, go to Execute Macro Script. And here you should already find the project folder in the list of folders. Please unfold it if it's not open yet. Click the arrow here, and there you should see the workshop1.py. If it doesn't appear, please click Refresh here. Select the file and then click Edit, which should open the Notepad++ editor. Now let me explain you the basic structure of a recorded GeoPython macro. GeoPython macro starts with a header, which contains information such as the geodict version that it was recorded with, the exact revision, the creation date, creation time, the username of the user which recorded the macro, and the platform on which it was recorded. This header is followed by a description text, which you can freely change. You can just edit these lines, and this text is shown in the macro execution dialog as information about the macro. Next up is the variables block. As I said, we're not going to be using variables in this advanced workshop. Please see the beginner's workshop for that. But in this block, you can define additional variables for your macro, which can then be defined from the user interface when executing a macro. Down here, you can find an explanation of the variable syntax and the different types of variables that you can use and how you define them. By the way, all these lines here, the explanation of the variable syntax, for example, is all so-called comment block. Comment is introduced by a hash sign and means that the interpreter will ignore the rest of the line. Further down, you can see the first argument block for the first command. You can see this is called create args1, and this contains all the data that is needed for generating the fiber structure that we made earlier. For example, you remember we changed the voxel dimensions to 100 by 100 by 100, and you can see these values here. And you could edit them here, for example, and run the macro again, and the change would take place. And you can see all these arguments here. They are in a so-called Python dictionary. And when we scroll down, at this point, the dictionary definition ends, and then the actual fiber geocreate command, which is the fiber structure generation, is called. And this whole dictionary, which was called create args1, is passed as an argument into this run command function. So what we see here again is the parameters for fiber geo and then the actual fiber geo execution. And this is followed by the flow simulation. Again, all the arguments for the flow solver. For example, you can find the tolerance and all the other stopping criteria here as well, and boundary conditions, etc. And again, this is followed by another run command call, which actually runs the flow solver. Now, one important feature of Notepad++ is, and this is the main reason why we suggest installing it, one of the main features is that you can actually fold away these huge dictionaries. So what this means is, if you see the minus sign in front of the create args1, if you click that, all of this will be folded down to a single line. You see that these lines still exist because the line numbering jumps from 63 to 209, but all these lines are just omitted from the display. The same you can do with Lear-Stokes arguments. And you see that the macro becomes much easier to read because now this just appears as 4 lines. Same you can do with the variables block and the description block and the header. And if you would like at this point, you could also remove this command block here. We're going to be making a lot of use of this folding mechanism later during this workshop. Now in the next step, we're going to look at how we can access simulation results programmatically from within GeoPython. But first let's look at a simulation result file. Go back to Geodict and click the File menu and click Open Results. Now double-click the Lear-Stokes result file here. This shows you the result of the flow simulation. And now let's say we're interested in the flow permeability that was computed in the process of the flow simulation. We can see in the result report up here, we can see the permeability tensor as the first item. And we can see that the permeability in the flow direction can be found here in the third row, third column of the permeability tensor. And this is the metric that people usually talk about when they talk about the permeability. And now let's say we want to programmatically access this result after running a simulation. Let's go to the Map tab up here, which shows you the actual internal data structure of the GDR result file. What we saw before was a human readable report, and now we see the actual dictionary which makes up the data. And if we look through these key value pairs that we can find here, we note that there is a permeability 3.3 entry down here. And this corresponds to this entry of the tensor, as we can see, because the values match. Now we remember the name of this key, and we will use this to access this permeability tensor from within GeoPython. So let's go back to Notepad++. It should still be open. If it's not, go to the execute macro dialog again, select the workshop1.py file and click edit, which will open Notepad++ again. Or you can just open Notepad++ from the start menu. And now the first thing we want to do, because we do not want to lose this macro as is, please go to File, Save As, and save it as workshop2.py. And this is a pattern that we're going to be following throughout the workshop. We always take the previous macro and save it under a new name and then do our changes. So please save the file. Now you saw that we have selected a file which was a so-called Geodict result file, which when opened showed us the result viewer with all the results from the flow simulation. Now what we need to do to access the simulation result from GeoPython is open this GDR file. What I would like you to do first is go to the very first line above the header and as the first line enter import string map. This is a Python module which is shipped with Geodict, which allows us to access files such as GDR files. And by giving the import statement, it will allow us to use this module. Now go to the very end of the file, and in front of the gdrun command function call here, please write gdr_name equals. The gdrun command here is a function call, which, as I explained earlier, executes, in this case, the flow simulation, solve Lear-Stokes. But this function also returns a value which is usually not being used. But this value is the name of the file which contains the results of this command. So we save the name of this file in a string variable called gdr_name in order to be able to open this file now. Now what we do is gdr equals string map dot parse gdr. Note that capitalization is important here. gdr_name. What this does is it calls a function from the string map module, which is called parse gdr. And this function opens a given gdr file. The file is given by name. It opens that file and extracts all the information in kind of a dictionary object, which is then returned and named gdr here. So inside this object gdr, after this line, we will find all the information contained in the gdr file. Now next, we want to actually fetch the permeability value from that file. For this purpose, write perm equals float, opening round bracket, gdr, opening square bracket, single quote, result map, colon, permeability 33, single colon, closing bracket, and closing round bracket. So this consists of several parts. What this does, this part does, gdr, result map permeability 33, is it takes this entry from the gdr file. And this is by default is a string. So this permeability number that we saw is stored as a string in this case. So the first thing we do afterwards is we convert it to a floating point number. So we can do computations with it, for example. We're going to need this in the future. And we store this floating point value in a variable called perm. And now, last but not least, we want to display this value. For this purpose, we write gd.messageBox perm. And what this does is it opens a simple message box, a dialog box with a OK button, which shows the given text or value. And now we go back to Geodict. Now we save the file, please, as workshop2.py, as I said. And now we go back to Geodict. And I will maybe keep this keep the editor open on the side, so you can refer to the source code. And now in Geodict we go to macro, execute macro script. And here, as I mentioned earlier, now we have a new file which Geodict hasn't registered yet, the workshop2.py. So please click refresh, and it should appear in the project folder. Now select workshop2.py and click run. Now please click override when prompted, and again click override when prompted. And now we see the message box, which contains the value that the flow simulation has just computed. So again, when we executed this macro, it has recreated the fiber. It has created the fiber structure again here. Then it has executed the flow simulation. And note that the flow simulation always happens on the current structure in memory. So because we do a structure generation here, it will have the fiber structure in memory, as it is displayed here. And then the flow simulation will act on this very structure that is in memory right now. And then we open the result file that the flow simulation has created, and we take the permeability 33 value from there, and we show it in a message box. And the reason why we had to click override, and we're going to have to do this a couple more times during this workshop, is that it has created the fiber geostructure under the same result name as before, because this is just a result name that was recorded. And the same goes for the flow simulation. It has also saved the it wanted to save the results under the same name. And because Geodict doesn't just override the file, it asks us if we want to override it. There's one more point which is important in the macro execution dialog, namely there is a help button down here, and there's a GeoPyRP help button down here as well. If you click the help button, it will lead you to the GeoPython automation user guide in your web browser, which unfortunately is not finished yet for the 2021 edition, so it will redirect you to the 2020 version. Here you can see the automation user guide. And the other button, the GeoPyRP help button, if you click that, it will give you a very concise summary of the GeoPython API. These are all the functions that Geodict gives you in addition to the standard built-in Python functions and modules. And all these functions are accessible under the prefix GD. And we already saw one example, which was the GD run command here. That is one of the functions which is part of the GeoPy API. But there are many more, as you can see here. And this also, for example, allows you to directly access the structure, change the structure, or access result fields and change them. Now let's go back to Notepad++ and first of all save the file again under a new name. So click File, Save As, Workshop 3. And what we're going to do now, before we dive into more advanced scripting, is we're going to be refactoring our code into a function, which makes it easier to use. So for this purpose, we go to the line just before the create args1 line. So no matter if you have this folded or unfolded, we just go to the line just above that, and we add a function definition. In Python, this works by writing def, then the name of the function. Let's call it create structure and run simulation. And this function will get a single parameter called SVP, which is the solid volume percentage, which is the opposite of the porosity. So we are now defining a function. It's named create structure and run simulation, and it takes a single parameter. Now next, please select all the lines below the function, so the whole rest of the file, no matter if it's folded or not, just select everything beyond that line and press the Tab button once. What this does, it indents all the lines that you have selected. Unfortunately, in Notepad++, this implies that all the sections get unfolded as well, but we can just fold them again. So click the button in front of create args and solve Navier-Stokes args. And as you can see here now, we have the function definition line, and we have all the lines below that indented by one tab. And this indentation is actually critical in Python, because the indented lines, the fact that these lines are indented below the function definition, means they're a part of the function body. So now we have moved all our macro code into a function, and if we were to call this function now, it would do the same thing that it did before. But as the function is nowhere being called here, running this macro would do nothing right now. But before we change this, we first want to incorporate this single SVP parameter that I've defined. SVP, as I said, is supposed to be the solid volume fraction, namely the solid volume percentage, namely the solid volume percentage of the fiber structure. So if we were to specify SVP value of 0, it would result in an empty structure. If we specify SVP of 100%, it would be a totally filled structure without any voids. So in order to make this happen, we first open the create args1 block, unfolding it, and then we go and look for the solid volume percentage line. In my case, it is at line 76, should be close for you as well. And we can see here that Geodict has recorded a constant value of 10 here, because that was the value that was specified in the FiberGeo dialog when we click generate. So what we do now is we replace this number 10 here by the variable SVP. So now if this function were to be called with an SVP value, it would be used as the solid volume percentage of the fiber structure. And as I said earlier, the fiber generation and the flow simulation always save the results under the same name. In order to reflect the SVP value, we now want to change the result file name so the SVP value is incorporated in the file name. So we actually know which result file is which. So for this purpose, we go to the result file name entry here in a FiberGeo block. And you can see here that there is a fixed name of FiberGeo GDR. We change this by putting a F in front of the first quote, which means format. And then behind FiberGeo we put an underscore, curly opening bracket, SVP. What this does is now the result file name actually depends on the SVP value. It will generate the result file name and put the SVP value at this position in the file name. And we're going to be doing the same thing with the flow simulation. So we can fold this block again, the create args1 block. And now we go to the solve Lier-Stokes args1 block, unfold it. And here we also have a result file name entry. And we do the same thing. We put a small F in front of it. And here we add underscore, curly opening bracket, SVP. So now whenever the function is run with an SVP of, say, 70 or something, it would generate the fiber structure with 70 in the file name, and the same for the flow result. So again, we have done three things. The SVP value is being used for the fiber structure generation. The result is saved under the name which contains the SVP, and the same happens for the flow simulation. Now we could call this function with a given solid volume percentage, and it would generate a fiber structure with that solid volume percentage, run a flow simulation on it, and return the resulting permeability. So this is a very convenient function that we can now use for our further studies. So now let's test this function by writing perm equals create structure and run simulation 25 and GD message box perm. So here again, indentation is really important. So in Python, we can see the def is at the very start of the line. Then all of this code is part of the function simply because it's indented here, because there's a tab in front. And the additional lines that we wrote, we have to make sure that they start at the very beginning of the line, and those are not part of the function. So when this macro is executed, first the function definition runs, which does nothing but define the function, and then the actual code to be executed is down here. And again, what this code does is it calls that function with a fixed SVP value of 25%. The function will compute the permeability, return it. So this is going to be, this part of the expression is going to be the permeability, and this is assigned to a variable called perm. And then this perm variable is displayed. Note that this perm variable is not the same as this perm variable inside the function. Now we can save this again by pressing Ctrl S. Then we go back to the macro execution control. Again, we probably have to hit refresh here. Select workshop3.py and click run. Now it will not ask to override because the new file names are called FiberGeo _25 and Lier-Stokes result _25. And those don't exist on the drive yet, so it doesn't ask us to override. And again, we get the result in a message box. But now we have our code neatly organized in a function. And that's it for the first part of GeoPython Advanced Workshop. And I'll be open for questions.